right? So there is a image given. That image has several pixel values. The size of the image is I think that is 4 into 4, right? So the image given, let's write down the image given. This is the f of x equal to, I can see that the first row of the image is 1, 2, 3, 4. Then we have 5, 5, 6, 6. And the third row is 6, 7, 6, 6. Then we have 6, 7, 2, 3. So any image given doesn't matter. We can still apply the method to find out the equalization of that image. Okay, right. Now this is a 4 into 4, so totally 16. Okay, so in order to perform the histogram equalization, first I'll make a table, right? And the first column will be the various levels that is present in this image. Okay, that's a gray level. So I'll simply, you can write the levels. So levels will be, normally I can see the highest number is 7. So starting from 0 till that number you can write. Okay, so that is 0, 1, 2, 3, 4, 5, 6, 7. Always this will be the first column of the table that we use for histogram equalization. Okay, that's the first thing. Then let's move on to the second column. In the second column of the solution, I'll write the number of pixels, right? You can simply write pixels. So this is actually the number of pixels that you are going to write here. In the sense, how many pixels in your image has value 0. So there are no pixels. 1 with 1 pixel. 2, I can see that there are 2 pixels, right? And 3 is repeated twice. So 3 also 2. 4 once. 5 twice. 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 6 times 6 repeats. 7 is repeated twice. Now, right, when I add them up, I should get the total number of pixels in the image. So this is 6 plus 4, 10, 11, 12, 13, 14, 15, 16. So yes, right, all the pixels have been considered so far. Okay, so that's the second column of my table. Right, once this is done, in the next step I will create what is called as the PDF, the probability of occurrence of the pixel. So I'll just write the PDF. So in order to get the PDF, the number of pixels divided by the total size of the image, that is what I need to consider. So just remember, PDF is, right, the number of pixels divided by the size of the image, right? In this case, size is equal to, right, I note that in this particular problem the size is equal to 16 because there are 16 pixels. Okay, so every pixel that I have here should be divided by 16 to fill the next column. All right, let's do that. So when I divide 0, right, you can write up to the 4 decimal points whenever required. Okay, so this is 0 by 16 will be a 0. Now I have to write 1 by 16. Okay, 1 by 16 comes to be 0.0625. Okay, the next one is 2 divided by 16, so that is 0.125. Next is also same, so 0.125. Then I have 1. 1 means 0.0625. Then we have 2. 2 means 0.125. Then we have 6 by 16, that is 0.375. then there is a 2 which corresponds to 0.125. Now, even in this case, the sum of the probabilities are always, whenever you take the probability, sum should come 1, so you can verify whether it is correct or not. Anyway, you don't have to do it right now. Actually, next column will help you out to make sure that you are correct. Okay, so we calculate what is called as a CDF, cumulative distribution function. So cumulative means you have to accumulate the values of your previous column to write a value in the current column. So you start with the first value itself, 0. But the next value is this plus this, right? 0 plus 0 0.0625 gives you 0.0625. Next value will be 0.0625 plus the next entry in the previous one. That is, I have to add 0.125 to get the answer in the particular column. Okay, so that comes to be 0.1875. To this, I'm going to add 0.125 to get my next value. That is 0.3125. Okay, to this answer, you add the next value, that is 0.0625. That is 0.375. Okay, the next value plus 0.125, that gives 0.5 plus 0.375 is 0.875. Okay, plus 0.125 equals to 1. So always you get 1 at the last, right? At the end of this particular curve, it has to be 1. Okay, if it is not 1, it indicates that some mistake has been, there is some mistake in my calculation. Okay, after calculating the cumulative distribution function, I have to write another value, that is the CDF into the highest, okay, into highest level, right? This is different for different problem. For this given problem, the highest level is 7. I can see that in my image, the highest level is 7. Right, so I should multiply by 7 to each of the values. So first row is 0, so 0 into 7 is 0. Then I just have to calculate, okay? 0.0625 is the first element. Multiply that by 7, right? You write whatever value you get, that is 0. Yeah, it looks like 4. Okay, so 0.4375. Next number, 0.1875 into 7 is 1.3125. 1.3125. Then the next number is 0.3125 into 7, that is 2.1875. Next number, 0.375 into 7 is 2.625. Then 0.5 into 7 is equal to 3. Sorry. Okay, the next number is so 0.875 into 7. So this is 6.125. Okay, and 1 into 7 will be 7. All right, and the final column is nothing but the new level. Okay, so you have to calculate a new level. This has to be calculated by considering which is the closest whole number for the entry in the previous column. So 0 means it is 0. 0.4 has a closest whole number which is 0. 1.3 has a whole number 1. 2.18 is 2. 2.6 has 3. 3.5 has 4. 6.1 has 6 and 7 is 7. So right, the histogram equalization is over, and the results are whatever pixels had 0, 1, 2, 3, 4, 5, 7, right, they have to be replaced by this particular value. That's all. That's the answer for the histogram equalization question.